Hello Year 12s, I hope you and your family members are safe and well. Welcome to another lesson. The title is Graph Transformations, of course. And just before we get started, reminder, coordinate geometry topic assessment is due next week. And today we're going to complete the graph transformations topic, and I'll set the graph transformations topic assessment, which will be due in 2 weeks' time. Now, notice that I gave you guys 2 weeks for the coordinate geometry topic assessment, and I will be giving you 2 weeks for this graph transformations topic assessment. So please don't rush it. Please take your time and make sure you practice with those exercise level 2 and 3 questions prior to doing those topic assessments, just to make sure you've seen a wide variety of questions on these topics. That would help you do better on the topic assessments. So focusing on today's lesson, graph transformations. As I said in last week's assignment, please make sure you watch this YouTube video, which is a YouTube video of my Year 11 graph transformations lesson, and please use these timestamps here to help, because look, realistically you won't need to watch every single part of this video, but maybe look at 28 minutes onwards. So you have translations, so stretch, reflections, and some completing the square, seeing how completing the square links with transformations as well, or specifically translations. One thing I want to add, the only difference in terms of GCSE graph transformations content and A-level graph transformations content, the only difference is that in GCSE they don't need to know about stretches, and at A-level you do need to know. But I included stretches as an extension in my Year 11 lesson, so everything you saw in that Year 11 lesson is relevant to you guys on the A-level graph transformations course, or I guess module. So look, here are the bullet points. We have vertical transformations where it affects the y coordinates. Nothing happens to the x coordinates. Horizontal translations, which affects the x coordinates and it does not affect the y coordinates. Combined translations, which means chances are there's been a vertical translation and the horizontal translation. Then we have stretches. Now, as I said, this is the type of transformation which is not assessed on the GCSE course. And of course, you have reflections and transformations of trigonometric graphs. Oh yeah, just here you can see a Desmos graphing calculator. So please make sure you have a go at just plotting graphs. You could plot, for example, sine x, y equals sine x on that graphing calculator, and then type y equals, I don't know, 2 sine x, see what happens. Try y equals, I don't know, sine x plus 2. Try different things and see what the outcome is. I think it's really useful to use a graphing calculator, just help you visualize what is actually going on. So I'm going to briefly recap some of the aspects which I guess the most important aspects of the Year 11 lesson. So here, just to remind you what a cubic graph looks like, what a reciprocal graph looks like. Then we have exponential functions as well. Remember, they're always either increasing or decreasing, and that depends on the x coefficient. So if it's negative, the exponential function will be decreasing. So transformations, as you can see here, the transformation is, well, the a is outside the brackets, and so it will affect the y coordinate. That's how I always remember it. If the value is within the brackets, it affects the x coordinate, as you can see here. affects the x coordinate, and if it's outside the brackets, it affects the y coordinate. So this is the GCSE content, and I'll show you the stretch slides as well. So let's look at this question. The diagram shows part of a curve with equation y equals f of x. The coordinates of a maximum point, so this one, are 3, 5. Write down the coordinates of the maximum point of a curve with equation y equals 2 f of x. So firstly, looking at this table here, the value is outside the brackets, so it affects the y values. It does not affect the x value, that stays the same. So the coordinates will be, firstly, we will know the x coordinate will stay the same. What will the y coordinate be? Well, it's 2 f of x, and so we do 2 multiplied by 5, which is 10. And also, if you were to draw it, the graph, how it would look like, it would look something like this. So it'll be twice as tall, if that makes sense. So yeah, sorry that the drawing is not the best, but yeah, I think you get the point. 310 is here, so that's our new maximum point. Now, here we have a question whereby, okay, they've given us the coordinates of a minimum point. Write down the coordinates of a minimum point of a curve with equation y equals f2x, so f of 2x. So firstly, the value is within the brackets, so it's inside, yeah, so it's inside the brackets, it affects the x value. So the y value is going to stay the same. The x value, however, instead of multiplying by 2, we have to do the opposite. And the opposite of multiplying by 2 is dividing by 2. So I'll write 3 over 2. And so, yeah, that corresponds to the new minimum point. Now, if we were to draw it, it would go somewhere. Maybe 3 over 2 would be somewhere here. So let's change the color. All of the x values are being halved. So one is going to be halved, and it's going to be here. All of these values here are going to be halved. So we're going to have something like this. Of course, this is the minimum point. And I mean, it's hard to tell, but let's say this is, I don't know, 8. Then I'm going to draw this until 4, because of course half of 8 is 4. Another thing I showed my year 11s is the link between completing the square and graph transformations. As you can see here, f of x equals this quadratic function. Completing the square gives another representation of f of x. And so, in relation to y equals x squared, we can actually plot our f of x, because we know that it's going to be, well, this is a combined translation. Step 1, so remember we start off with f of x, which is this blue curve. Step 1, x take away 3 squared. Remember, it's going to affect the x value. Y value doesn't change. And because it's take away 3, we have to perform the opposite of that, which is becoming more positive. So the graph will become more positive. So it's going to be a translation with vector 3, 0. So here is the new minimum point, and I'll just draw a rough curve. Now step 2 is adding 4, and as it's outside the brackets, as it's not related to the x, it's going to be a vertical translation. And so if you move up 4 spots, our new minimum point will be here, and of course it would be, our new graph is this red graph. I'm now going to go through a few GeoGebra links. So these can be found on Integral Maths as well. These two explore links, those are the ones I'm going to go through now. But of course, if there is anything you're unsure about, then please watch these videos as well. If you'd want another explanation on translation, stretches, reflections, then yeah, please make sure you watch these videos because they will help you a lot, I'm sure. Now let's start looking at these links. So I'll start off with this one here. So there are two options. Okay, let me click on this. Yeah, now it works. Yeah, so there are two options: quadratic functions or reciprocal functions. So let's start off with a quadratic. I'm not going to spend too much time on this because I think it might get quite repetitive, but if you adjust the a value, of course the a value is within the brackets, so if you adjust the a value, you're either going to shift your graph to the left or to the right. Now of course remember, when a is, so when it's x, take away 1, take away 2, take away 3, we're shifting it to the more positive side, so we're actually doing the opposite. And of course when it's f of x plus 1, f of x plus 2, f of x plus 3, we're shifting it to the more negative side. So bear that in mind with, just always remember with when it's within the brackets, when it's affecting the x values, the opposite procedure takes place. Of course, with b, it's a lot more simple. 1 means you shift it up by 1, 2 means you shift it up by 2. Same thing if you were to shift it down. It's of course represented by a negative value. I'm gonna now have a look at the stretch transformations. So let's start off with a equals 1, just so we have one graph on there. So this is, look, no transformation is taking place, sorry. So if it's f of x, let's do f of 2x, the graph, all the x values are being halved. Look, none of the y values are changing, but all the x values are being halved. Likewise, if we were to go the other end and write f of 0.5 multiplied by x, all the x values are being multiplied by 2. Look, you go from 2 to 4. Of course, 0 times 0 times 2 is 0, so it stays at 0 at that point. But yeah, there's a linear function which you guys can have a look at and see what happens here. Well, let's just focus on the quadratic for now. Here we have a, let's just change this. Yeah, here we have a stretch which affects the y values. So let's just try 0.5, we're halving all the y values. Yeah, and 2f of x, as we saw in the previous example, we're multiplying all our y values by 2. So, for example, this minimum point is -1, as in the y value is -1. So the coordinates are 1, -1. The new minimum point is 1, -2. Why? Because the y value, which is -1, is being multiplied by 2. Now let's have a look at the trig functions. Now, don't think I've talked about trig functions so far in today's lesson. So firstly, as you can see, there's a lot going on. So let's just change a to 1. So there's only one function on the screen. And of course, you could toggle between sine, cosine, and tangent. I'll just focus on one because, again, I don't want it to get too repetitive. One thing I want to discuss is a few keywords. So sine, cosine, and tangent graphs are all periodic. What that means is they repeat. So here, this sine graph starts at 0, 0. When it gets to the coordinate 360, 0, then it starts repeating. You can see it starts increasing again, then it starts decreasing again. So yeah, each period on a sine graph lasts 360 degrees. Now let's have a look at the cosine graph. It starts at 0, 1. The next time it hits 1 is at 361. So it also has a period of 360 degrees. Every 360 degrees, you can see it repeating itself. Moving on to the tan graph, each period lasts 180 degrees because we know that at the line x equals 90, we have an asymptote, and then at the line x equals 270, we have another asymptote. Between those two asymptotes, we have a curve, and that curve is repeating. As you can see, if I zoom out a bit, that curve is repeating every 180 degrees. Another key word I want to mention is amplitude. Now, unfortunately, I can't write on this screen right now because it's on the internet, but please make sure you make a note of these keywords in your books. So amplitude is the distance between each peak and trough on this sine graph, the distance between each peak and trough to the x-axis. So right now, it has an amplitude of 1. If we have a look at the cosine graph, this also has an amplitude of 1. If we were to change this a value, let's just focus on sine for now. If we were to change this a value, so we have the graph of y equals 2 sine x. Now the amplitude is 2 because the peak here at 92, that has a distance, a vertical distance of 2 to when it hits the x-axis. Also, if you look at the trough at 270, -2, the distance between the x-axis and that trough, that minimum point, is also 2. So by changing this a value, we're changing the amplitude, and for example, here we have an amplitude of 3. If we go, here, then we have an amplitude of 0.5. I'm just going to go through a few of these transformations. Here, of course, we are affecting the y values because the a is outside the brackets, it's not next to the x. If we were to move to the second type of transformation, let's write 2. It says y equals sine 2x. Again, each x value is being divided by 2. So where we had the coordinates 180, 0, the new coordinates is 90, 0. Where we had 360, 0, the new coordinates are 180. So now this blue curve is also periodic, but the period has also been halved. So you know how y equals sine x has a period of 360 degrees, as you can see on the blue curve, the periods now are 180 degrees. In other words, every 180 degrees, this curve is repeating itself. Now let's move on to the translations. So we have y equals a plus sine 2x. Let's just keep it at 1. So it's being shifted one place up, and if it's within the brackets, it's going to be shifted horizontally. So let's start at k equals 0. Sorry, wow. Okay, k equals 0. Oh my god. Yeah. So if it's x plus, I don't know, 50 or something like that, then we will shift to the left. We will shift to the more negative side. And if it's x take away a certain number, then we will shift to the more positive side. Just remember that. The principle is just the same for trig functions. So now we're going to move back to our PowerPoint. And your first independent task is to complete at least 4 questions from the exercise level 2 questions. After you do that, please mark your answers using the solutions on integral, and then come back to this video because we will be answering some harder questions, some problem solving questions. So yeah, hopefully you guys get some good practice with these exercise level 2 questions, and then you can come back to this video to try to answer the problem solving questions. So your problem solving task is to try your best to answer these 3 questions independently. As I did a few weeks ago, I will be providing hints to help you if needed. So here we have question 1, lost in translation. So the blue curve on the right is a translation of the red curve. What is the equation of the blue curve? So pause this video if you want to get started right now. If you want a hint, then don't pause the video and I'll give you a hint in a sec. Okay, so the hint I'd provide here is we've been given our function, we've been given our f of x. So this is our f of x. Think about what translation is taking place for this red curve to end up in that position. We can see it. It's going to move to the right and then it's going to move up. So think about that. Hopefully that hint helps you to answer this question. So now pause this video, try to answer it. Okay, we're now going to go through the answers. So here they are. As I said, this was our f of x. I can see, let me just change the color. I can see that we are moving 1, 2, 3. 3 places to the left. 3 places to the left. So step 1, f of x. We're moving to the left. So I will write plus 3. And then we are moving 1, 2, 3 spots up. So f of x plus 3. Then we're just going to add 3. So we use our knowledge of composite functions. Instead of writing x squared and 4x, we're going to write x take away 3 squared. And instead of 4x, we have 4 multiplied by x take away 3 plus 2. And then, now we've done this bit, then we just add 3 at the end. And so by expanding brackets and cleaning that expression up, we end up with this quadratic expression. Here we have the second question. So again, feel free to pause this video right now to get started. If you would like a hint, then keep playing on and I'll provide you with one. Okay, so in terms of a hint for this question, again, they've given us the function and, well, firstly, I can see a reflection is taking place. However, it looks like a combined transformation, so it will be a reflection followed by a translation because it's not an exact reflection in the x-axis. I can see it's being shifted a bit as well. So hopefully that helps you. So yeah, pause this video now, try to answer the question, and I'll go through the answers in a sec. Okay, so I'm going to go through the answers now. Okay, as I said, the first thing I noticed here is that it's obviously being reflected in the x-axis. So let's use a green pen to demonstrate. It's going to be something like, so this is -4, so it's going to have a maximum point of 3, 4. It's going to go something like this. Okay, this is 5, so I'm going to draw this to 5. Okay, again, it's not the best curve in the world, but yeah, I hope it makes sense. Yeah, so this is where we are. So the first transformation, so this is f of x. Our first transformation is f of, so it's the y values are changing, the x values are not changing. So it is a reflection whereby the negative sign is outside the brackets. So now we can see it's being shifted down. Let's use orange. It's being shifted down 4 spaces. 4 spaces down. So now I'll do take away 4. So this is the full combined translation which is taking place. So we can see that this is our f of x. So negative f of x will be negative x squared plus 6x take away 5. Then we just take away 4. And if we do that, we will end up with this as our answer. Here we have question 3. Once again, please pause this video and get started if you can. If you want a hint, then keep listening and I'll provide you with one in a few seconds. Okay, so my hint here is by looking at this equation, we already know that the transformation is not going to affect the x values at all. And that's because this x is completely by itself. It's not being multiplied by anything. We're not adding anything to that x within that brackets. And yeah, so that's your clue. X values are unaffected. Have a think about what combined transformations are taking place for us to get this function. So I'm going to go through the answers now. Firstly, I'm going to use my understanding of those keywords. So I said period and amplitude. So firstly, the period is just 360 degrees. It's not changing. However, the amplitude of this graph is different to the amplitude of a standard sine graph. So let's draw a sine graph. Actually, I'll just use the same color. Let's draw a sine graph here. Oops, that looks a bit weird, but yeah, it's just gonna go like this. So this standard sine graph, what is the distance between the maximum point and the minimum point? Well, of course it's 2, because we have 1 plus 1 equals 2. What is the distance between the maximum point here and the minimum point here? The difference is 6. 6. So it's very clear that we will be multiplying our sine x by 3. So that's the first transformation. All right. Y equals 3 sine x. And let's do a quick sketch. So 3 negative 3. So it will go something like this. So that's our graph for y equals 3 sine x. So right now we have y equals 3 sine x. So we're almost there. But this graph has obviously been shifted up by, let's see how many places. So here the maximum point is 3. Here the maximum point is 9. So we're shifting up by 6 spots, 6 places. So right, plus 6 here. Now we need to work out a and b. So I just need to change the form in which presenting this answer. So 3 open bracket sine x plus 2. These two are the same thing. So what are the values of a and b? Well, a equals 3 and b equals 2. Now I will ask you to go back to integral maths and complete at least 2 questions from the exercise level 3 questions. After you've done that, then I'd like you to mark your answers. And it's really important to get this extra practice, because hopefully if you are able to answer a number of questions from exercise level 2 and exercise level 3, then I am sure you will find the topic assessment, okay, I don't want to say easy, but you will be okay with the topic assessment. So yeah, last thing I'm going to say, remember topic assessment for coordinate geometry next week, I think 9th of March, and the topic assessment for graph transformations is due a week after in our lesson in 2 weeks time from now, which is the 15th of March. Thank you very much for listening, and please make sure you ask me for help if you need help. And yeah, make sure you enjoy the rest of the day and have a great week as well. Take care, everyone.